From frustration to focus, AI's impact on front office operations. Hi, I'm Scott Sawyer, co-founder and chief scientist of Paperless Parts. For the last 18 months, I've been really focused on AI. Everyone's talking about AI, and in this presentation, we'll take a slightly different approach. We'll focus on AI in the front office, and we'll also go in and get into the weeds and actually break down how some different types of AI work so that you can understand how to make choices about which tools to use a little bit more clearly. Today's goal is to understand how, where, and when to use AI-based solutions to level up your shop. The agenda is I'll briefly tell you a bit about paperless parts, then we'll go into the different types of AI and how they actually work. We'll look at examples of AI in manufacturing today, bring up the risks to keep top of mind and questions to ask vendors and partners, and we'll look at how to leverage AI in your shop's front office. To start, Paperless Parts is a software platform for manufacturers that help you quote custom parts quickly and accurately, and we help manufacturers in a number of ways. For larger shops, we're quoting as a team sport. We have workflow management that helps estimators work on the most important parts and managers know exactly what's going on, so you're responding quickly to your best opportunities. Our team works with you to implement the way you cost in paperless parts, which means costing is automated and consistent. When you get a CAD file, we unfold the part or analyze the part for machining and other processes. We figure out things like bends and cut lengths, feature detection, and manufacturability issues. And all of that is used to set up your materials, routing, runtimes, and costs. We deliver a great experience for your customers, giving them a rich digital quote with options for quantities and lead times. They can submit a PO or even pay with a credit card. And finally, we've got great open APIs that connect paperless parts to other systems. So we integrate with the top ERPs, which means after you win the job, all that routing and costing goes right to the shop floor. We also integrate with metal providers and hardware distributors so you can get instant pricing and availability when you're quoting. We have some of the biggest custom part manufacturers in the US. If you think your logo should be here, or if you're interested in learning more, check out paperlessparts.com, and we've got a great team that can help figure out if we'd be a good fit. So with that in mind, let's talk about what's going on in the industry right now. In the wake of COVID and conflicts on the other side of the world, OEMs are looking to reshore and maybe relax some of that just-in-time inventory management that's been so popular for a while now because it's risky, right? So we're seeing a lot of investment, both public and private, to expand capacity and capabilities in the United States. So that means there's a lot of opportunity out there, but it's also competitive. And who are the winners? So obviously being efficient helps you compete on costs, and that's great. But we're also seeing huge growth of what I call digital manufacturers because they're easy to work with, and OEMs have confidence in their costs, lead times, and quality. So there's two trends powering this that go hand in hand, and that's artificial intelligence and cybersecurity. AI unlocks great new capabilities, and at the same time, OEMs are paranoid about their intellectual property. So let's break that down. What is AI anyway? There's no authoritative definition, right? I'm an engineer, I make software, so to me and my team, AI's really come to mean generative AI, right? Which are massive scale artificial neural networks that can create text, images, and videos. So this is distinct from machine learning, algorithms, and expert systems. And in a few minutes, I'll get a little technical, but I'll keep it light, no equations, no math, right? And I'll break down what each of those different technologies actually does to work. Of course, there's also other definitions for AI, right? So in the marketing world, it's used, especially in the last 18 months, to refer really to any kind of automation or prediction, from simple if-else logic to large language models. Which one's right? Well, it totally depends on the context and the audience. So, you can call AI whatever you want, but of course, if it means everything, it also kind of means nothing. So let's actually walk through what each of these different technologies does that gets called AI and get a flavor for what they are and how they work. But first, if you haven't seen this before, this is called the Gartner hype cycle. And just about every new technology follows this pattern, right? So some new technology hits the scene and there's a technology trigger. So let's just play this out for something like 3D printing, which I think most people in manufacturing are familiar with, right? So back in, I think it was the 90s, you started to see affordably priced, reasonably sized 3D printer technology, and people got very, very excited about it. In fact, they got too excited about it, and we ended up at this peak of inflated expectations, right? Where the hype was really high shortly after this tech came out, and people started thinking things like, all other manufacturing processes are going to go away. There's not going to be any machine tools. Everything's going to be 3D printed. Supply chains are going to be completely revolutionized, right? And then what happened is that hype crashed, and we ended up in this trough of disillusionment, right? Some companies' stock crashed, some companies went out of business, and generally people got a pretty bad impression of 3D printing. But gradually over the years after that, we found really good applications for 3D printing and additive manufacturing. And that's what we call the slope of enlightenment, and then finally the plateau of productivity, right? So now there are lots of good use cases for it. It hasn't replaced every manufacturing technology, but sure, lots of parts are 3D printed, and there's some great use cases for that. So let's now talk about AI, right? Artificial intelligence is definitely a real thing, and it's here to stay. And at the same time, it's going to follow this hype cycle, right? So we have the technology trigger. We are still on the way up of inflated expectations, right? People are thinking it's going to change every aspect of life. It's going to replace every job. There's going to be some overhype that happens. And then there will likely be a crash, right? And we'll go into this trough of disillusionment. Something horrible will happen. Hopefully it's not too bad. But then gradually we will figure out how to live with AI. We will find the great applications for it. We'll realize there's things it's not great for, and we'll use it. And it'll be used across probably every industry and all types of jobs. Now, that said, it's easy to sort of dismiss this, right? But in terms of significance, AI is really, really important and significant. So I would compare it more to something like the internet in terms of its impact and how much it's going to mean to society, as opposed to, say, blockchain, which I think is something that fizzled out and is not going to be as huge a part of society as like the internet and artificial intelligence. So not all artificial intelligence is equally intelligent. And I said I'd break down the different types of AI, so let's do that to show that there's very different levels of sophistication. And that doesn't mean that simpler techniques are bad, right? Everything's a trade-off, and it's all about finding the right tool for the job. So I'll outline these techniques, and I'll point out examples in our own product of where we're using each of them. So to start, let's talk about algorithms, right? So this is just a technical term for writing lots of code, right? Algorithms automate processes or predict hidden values given observations. You might use data in the development of algorithms, but not so much for the machine to automatically learn something, but more for generating test cases or maybe measuring the performance of your algorithm. Examples, in Paperless Parts, we use it for geometric interrogation. So if you upload a 3D model to Paperless and say you pick a machining process, well, we're going to analyze that 3D geometry. We're going to identify features like cutouts, pockets, holes, things like that from the raw geometry, and we're going to highlight manufacturability issues. So how do we do that? Algorithms, right? We've got a bunch of computational engineers who write code to identify these situations. Is it AI? Some people might call it that. Some people wouldn't. Another type of AI is expert systems. So this is a term that was actually popular back in the 1980s. I'm bringing it back. And what it really just means is encoding domain knowledge into software. Okay? So an example in Paperless, and I'm seeing this similar things in other software, is we have this feature called Found in Files. And when you upload a print, we look for certain things in that print. And one of the areas is we'll look for specifications, right? So we've got a database of specification names, and we just look for the occurrence of those names anywhere in the print, right? So how do we do it? Well, it's pretty simple. We just have a list of specs, and we search for all of them in the text. Again, is it AI? It's certainly not generative AI, but it's a useful tool for certain things. And now, let's talk about things that get a little bit more interesting, right? So what is machine learning? Now, say we get a little bit technical, and there's 2 technical slides in this presentation, and here's the first one, right? So in machine learning, an equation or model is learned from training data, right? And the way to think about this, if you're not familiar with ML, is like a trend line in Excel. So if you've got some data in a spreadsheet and you graph it, right? And you get that line, or maybe you've got those points. You can draw a trend line through it and then use that trend line, right, to predict if you've got something outside or between those points on your plot, right? And that's essentially maybe the simplest example of machine learning. So it's a model that's used to predict or infer something about new unseen data samples. And one thing is that data scientists have to use their domain knowledge to convert the raw data into a numerical format that's usable by ML. So an example of where we use ML in Paperless Parts is when we extract certain pieces of metadata from a print. So for example, getting the part number in a revision. The challenge there, that sounds pretty straightforward, but it turns out prints vary widely from OEM to OEM and even engineer to engineer. And you can't always look in the same place or expect the same label to be, or any label to be near those things. So we found that you actually need some machine learning based on looking at a large number of prints to be able to pretty robustly find those things off of any print, even in a format you've never seen before. Okay, so this is where it starts to sound a little bit like magic, right? So how does that work? And what I'm going to try to do here is explain machine learning with a simple example in just a couple minutes. So let's see if we can do this. All right, so here's the premise. We're going to use machine learning to detect part numbers off of engineering drawings, okay? But we don't want to make an assumption about where that part number is going to be or what the format's going to be or what text is going to be located near it or even the format of the part number itself because all OEMs have different formats of part numbers. Okay, so that makes the problem significantly harder because you can't just code some rules up to go look for this string, which is the part number. So how might you do it? Here's a way to do it. The way we actually do it is quite a bit more complicated, but this should give you a flavor, an idea for how machine learning works. All right, so here's what we're going to do. We're going to go through every word on every page of these prints. And what we're going to do is we're going to convert the word into three numbers. And those numbers are going to be X, Y, and Z. And those three numbers are going to be computed like this. First, we're going to count the number of digits, the number of numerical digits in that word. So in this example, if this is our part number, we've got 1, 2, 3, 4, 5, 6, 7, 8 digits. So our first number, X, is 8. Then the next number, Y, is going to be the number of non-numerical digits in that word, or I should say characters in that word, and that's going to be 3 because we have a P and another P and a dash. Okay, so we got an 8 numerical characters, 3 non-numerical characters, then the last number, Z here. Let's say that's going to be the distance between the center of that word and the bottom right of the page in, say, millimeters. Any unit works. Okay, so now let's say that's 28.5, whatever that is. All right. So intuitively, can you believe that the composition of the characters in that string or word and the proximity of that word to the bottom right of the page gives you some kind of indication about whether that particular word is the part number for that print? Intuitively, you probably would say, yeah, I think that's actually going to tell you something about that. So in a machine learning world or algorithm, what we would do is we would take all the words in our data set and all the ones that are not part numbers, we're going to go plot those. And I picked 3 numbers, X, Y, and Z, so that you can kind of visualize how you might see this on a graph, right? So if we graph those in 3 dimensions, all the words that aren't part numbers, we could graph in red. And all the numbers that are part numbers, we can graph in green. And if you've picked good numbers that you've extracted from those words, we call those features. If you pick good features, you'll find that the green and the red are kind of separated on your 3D plot. Now, real life doesn't work out quite this beautifully. Usually there's a lot more mixing. It's not as clear cut. But what machine learning does is it's going to find a division point, right? In this case, we have this nice flat plane that divides the reds from the greens, all right? Now, if I get a brand new print from, say, an OEM I've never worked with before, I have no idea how they structure their part numbers, where they put them, and so on. In theory, what I can do is take this machine learning model, compute my X, Y, and Z value for every word on that page that I've never seen before, and see if any of those words land in the green zone. If so, that's my guess for part number. So that is in the simplest example how machine learning works. All right, so that was machine learning. That's now considered old school. My engineers don't even want to call that AI. So now let's talk about artificial neural networks. All right. So in technical settings, AI usually refers to these artificial neural networks, right, which are essentially small simulated brains. And these neural networks have been around since the 1950s, but they've had a huge change in capability in the last 18 months or so, 18 to 24 months. And this is due to both the scale of these networks and the architecture that people have used to create them. So the networks learn by comparing the output of that network against the desired output, and then adjusting the network to get closer to the desired output. So we'll talk about how that works in just a second. We'll again get just a little bit technical. All right. So in Paperless Parts, we use technology like this. We actually use a large language model, or LLM, right, which is a big artificial neural network, to look at natural language in email threads, right? So if you get an RFQ email from a customer and forward it to Paperless Parts, we have an LLM read that email message and look for part numbers and quantities being requested, right? And it doesn't matter what the format is or how they phrase it. There's a good chance the LLM will be able to figure out which words in that email are in fact part numbers and quantities being requested. Okay, so now we're getting into AI techniques that really do sound like magic, but yet it's real and it works. So how? All right. So here we go. A couple minutes on neural networks. The thing on the left, right, that is a cartoon of a neuron or a brain cell. And we've got about 86 billion of these in our brains. And between the nerve cells, there's about 100 trillion connections. And the way they work is up top, you've got these branched nerves that come into the cell, and those are called dendrites. Those are essentially the inputs into the cell. And then you've got this cell body or nucleus here in the middle. And the inputs, what they're receiving is electrical signals, right? And it builds up this electrical charge inside the nerve cell. And when it reaches a certain threshold, it starts firing out electricity to its outputs. So its outputs are these nerves down at the bottom. They're called axons, okay? And those go to the inputs of other nerves. So each cell itself is really simple and not intelligent, but when you start to build up huge networks of these and connect them, just amazing things start to happen. So the thing on the right, that's a diagram of a neural network. Each circle, think of as a neuron or a nerve cell, and each line arrow between them, right, is a connection to another nerve cell in another layer. So when we simulate them, we typically do them in layers like this. There's different architectures, but this one is pretty typical with some variations. And you can think of the layer on the left here as maybe an input, and the layer on the right is an output. So let's talk through an example here. One of the first effective applications for artificial neural networks was OCR, or optical character recognition. So OCR is when you scan a document or take a picture, and the computer is able to figure out text in that scanned image or photo, right? So that's like when you scan a document and then you run OCR, you're actually able to highlight the text and copy and paste it. Or something I've recently noticed on my phone is if, say, you take a picture of even a t-shirt with words on it, right? It actually will pick up what those words are, which is pretty amazing. That's OCR, and it's typically powered by a neural network. So in the simplest example, let's say we want to make a network that takes a small image of just one letter and tries to figure out which letter it is, right? But it doesn't matter if the pixels exactly match some letter it's seen in the past. So every A it sees might be just slightly different. So it can't just look up and see whether it exactly matches an A. It's got to learn, what it means to be A, right? So what we would do, that would be our input, right? So if we have an image, let's say it's black and white, right? Each pixel can be represented with a 0 or a 1 for black or white. And you can have an input layer that goes, it would be much more than 4 neurons. It would be big enough to get each pixel in that small image. All right, that's the input. So we're going to put black and white pixels into this network. Then these connections are going to kind of percolate that message through the network, and then at the output, maybe we have 26 neurons at the output for letters A through Z. And ideally, when you put an image A into the network, the output will be a nice strong signal at the A neuron, the first one, and 0 or a low signal in all the other neurons, right? What's going to happen when you start training this, that's not what's going to happen. You're going to put an A in and it doesn't know what it is. But what you can do is you can adjust the network, right? You can change the connections between all these neurons just slightly so that the output gets a little bit closer to what you're looking for. And you can do that over and over and over again. And over time, with enough training data and enough time, you will start to get a network that actually solves your problem. And that is remarkably close to how the human brain learns and works. Okay? And then all these amazing behaviors, when these networks get massive, these amazing behaviors like the ability to draft an email or generate a video just sort of emerges. And these networks aren't explicitly programmed to do those things. All right. So that was AI in a couple minutes. Let's now talk about where we've been seeing AI and CAD in manufacturing. There are quite a few tools out there. So let's look at some examples and let's talk about the likely technology underpinning those, right? And I'll highlight a few I've seen recently. So one example, there's a great company called CloudNC, and there's some other companies doing similar things where they've created essentially automated CAM, computer-aided manufacturing, or tools that at least assist you in making CAM more automated, right? And a lot of people call these AI. That's fine. These are really interesting and cool tools. What's powering them? Well, I suspect it's a lot of algorithms and maybe a little bit of machine learning and AI, but probably a lot of code to find effective tool paths. Another example I saw recently was this cool interface called text to CAD, where you can just type a phrase, like in this example, a spur gear with 13 teeth, hit go, and it would generate you a 3D model that matched your description, right? So how does that work? I tried it, it worked. Well, probably it's using a large language model, something like ChatGPT, and it's prompting that large language model to propose a set of steps to execute in a CAD program that would create the desired 3D model. And then it probably just runs those steps in some CAD software and sends you back the model that comes out of it. Okay? So yeah, I would call that AI for sure. It's an LLM at its core. And then we've seen other things like I saw on social media someone posted a video of someone had an engineering drawing flat on the desk, and then they took a phone and pressed a button, and a second later there was a 3D model from that drawing. What's powered by that, right? If the first one's algorithms, the second one's AI or LLMs, this third one is likely hopes and dreams, right? I don't think there's technology out there yet that lets us go from a rough 2D drawing in general to a reliable 3D model. I'm sure in some very simple drawing cases it can be done, but believe me, I look at engineering prints every day, and they are really hard to interpret, and there's not yet automated technology close to being able to reliably generate you a 3D model of that you could then go, for example, quote or manufacture. So I guess the moral of the story is there's different flavors of AI, and also there's a lot of stuff that is getting kind of touted out there that isn't necessarily real or isn't really yet. Still, there are lots of examples of AI in manufacturing today, a lot of areas where it's going to make a big difference. Some are available now and some are on the horizon, right? So if we think about CAD and CAM systems, these systems are hard to learn how to use. So there's huge potential in making these tools more accessible, right? So with generative design, can people without extensive experience in these tools generate 3D models or edit them, right? Another one would be natural language analytics, right? Have you ever wasted a whole bunch of time trying to pull the right reports, write SQL, try to get information out of your ERP system? Well, wouldn't it be cool if you could just express your question in plain language? Just ask your business question to a tool that would then go figure out how to build out that query and get all that information out of a database into a report. That would be awesome. Another one is augmented reality for operators, right? Can be a really tough job to figure out where to go find a part or some material, or how to assemble something. We're starting to see a lot of technology enabled by, for example, wearables like glasses that just help the operator very quickly figure out what to do next without having to, while still keeping two hands free and without having to take their eyes off their work. That can really speed things up, make that job a lot more effective. Another one is process control and optimization, right? Everyone's trying to do continuous improvement. AI can definitely help there by finding insights and looking for ways to optimize things. Downtime labeling and shop floor optimization, really similar. Can you have a tool that knows how to identify downtime and maybe label or predict why it happened? Because operators aren't always reliable sources of information about that. Then autonomous and learning robotics, right? So if you've been to a trade show recently over the last few years, just a ton of robotics, lots of arms, lots of progress in that area. The future where that goes from here is making those easier and easier to program so that you don't have to explicitly have it do the same thing over and over again, but sort of teach it its job and have it figure out how to do it and react to a changing situation in ways that they can't necessarily do today or haven't been able to do in the past. So the too long didn't read here is that AI is powerful. It's going to be everywhere, lots of applications for it, and with great power comes great responsibility. You really can't talk about AI without addressing the potential risks to your business and really everything, right? So the first thing is data privacy. So what we're seeing is most software products out there that are just sort of bolting on AI, they're doing it by integrating with a third-party system like maybe OpenAI or ChatGPT, right? And maybe you trust your vendor with your data, but do you trust your vendor's vendor? Do you even know who they're using and what they're doing with your data? That could be a big concern for you, depending on lots of things, right? Where the data is coming from, who owns it, and so on. With generative AI, meaning AI that creates text, images, and videos, there's also a big concern about copyright and plagiarism, right? Because sometimes the output it produces is really similar to some of the input it's been trained on, all right? So could using those tools potentially get you into legal trouble because you've created an image or a blog post or something that looks just like someone else's, and now you're in trouble for copyright violations. Another thing is incorrect responses, right? AI gets things wrong a lot. So you need to make sure you're aware that it needs to be reviewed by a human when it really matters. Hallucination, right? Sometimes it's not just wrong, but it makes no sense at all. And that can be embarrassing, right? If that's out there representing your company, if you're sending out emails to people generated by AI and it's hallucinating things, it makes your company look bad. Safety is another one. Physical safety concerns. So if you have AI controlling processes or robots, there's this very obvious safety issue that you need to make sure no one gets hurt physically. And it's also worth remembering that there's harm that can be done even if it's not interfacing with the physical world, right? Just with text and images, there's harm can be done with those things. And the future of work. People are rightfully concerned about classes of jobs being displaced by AI, and that is absolutely something that we all need to talk about and plan for. So with that in mind, a lot of the shops we work with do defense work, and they're all subject to CMMC. They're dealing with that right now, Cybersecurity Maturity Model Certification. So this is a new program that will protect a certain type of government data called Controlled Unclassified Information, or CUI. And a lot of people have heard of ITAR data, right? That is one category of CUI. CMMC is going to be required on Department of Defense contracts and then flow down from the prime contractor to everyone in the supply chain who touches this data. What CMMC requires is a third-party certification that you've met fairly stringent security requirements. ITAR registered fabricators likely need to be at level 2 of 3 for CMMC, which is 110 controls or requirements based on a NIST standard called 800-171. The reason I bring this up is most AI is provided by cloud services. And in the CMMC world, beyond the 110 controls that manufacturers have to implement, there are even more stringent requirements if you're going to use a cloud service and send CUI to it. In particular, the three big requirements on these cloud providers is, first of all, they need to be staffed by 100% US persons, meaning anyone at that cloud service provider who could possibly have access to your data needs to be a US person so that it's not unintentionally exported. That cloud service provider has to sign up to certain incident reporting requirements and incident response requirements. So if there is a breach and it somehow involves their systems, the DoD can basically show up and launch their own investigation, and you need your cloud service provider to agree to that. And then finally, the cloud service has to meet a very stringent security standard called FedRAMP moderate equivalency. So this is significantly larger than the CMMC level 2 requirements themselves. And this is actually pretty rare in the manufacturing space. There are not that many vendors out there that have met these requirements. So, AI in manufacturing. On the one hand, we have really powerful tech that can help your business out. We now know there are some risks. So how can you actually get started with AI as a manufacturer? Well, there's a spectrum of solutions, from general purpose to industry specific to fully custom solutions. And on the general purpose side, you've got tools like ChatGPT, Google Gemini, Microsoft Copilot, and these can help you make everyday tasks easier. You can use these tools today to get stuff done quicker, almost regardless of what your job is. They're good for doing things like research, drafting an email, writing Excel formulas. If you're struggling with that, you can describe the spreadsheet and ask it to write the formula for you. You can work through some tricky data analysis, even write SQL with it. You could, for example, summarize a manufacturing spec, and on and on. There's lots of ways you can speed your work up with these tools, right? So that's general purpose. In the middle, we've got industry specific. And of course, I put paperless parts in this category. So these are software tools, right, sold to particular industries that have integrated AI into their product to solve your manufacturing problems. So by buying and adopting these tools, you're leveraging AI. So this is another very effective way to be able to take advantage of AI and help your business out. And there are a lot of players in this space. These are just a few that kind of come top of mind when you think about AI in manufacturing. And then on the right, you have custom solutions built for or by your business. You've probably heard a lot of these company names, but the thing to realize is these logos aren't really off-the-shelf solutions in most cases, but rather they're platforms for building solutions. So when you think about Microsoft Azure and Amazon Web Services and those tools, those are platforms. They likely don't have a ready-to-go solution that's just going to solve some business problem you're struggling with, but they are really good platforms to help you efficiently build a custom solution or have a vendor build a custom solution for you that does solve your business problem. So this is the spectrum we use to think about different AI tools out there. So if you're starting to think about AI and partnering with a vendor, you need to really think about and get answers to these questions. Where is AI used in your application? What third-party services or partners do you use to provide the AI capabilities? How is my data used to train your models? How can I tell when data has been generated by AI? Have you had a third-party audit for cybersecurity? And by the way, this goes beyond AI vendors. If you're using really anybody's software, you should at this point be looking for some sort of third party to have looked into the cybersecurity of that tool. So in our world, where we work with a lot of defense contractors, the gold standard is FedRAMP. In the commercial world, you see a lot of SOC 2, and you'll also see some ISO 27001. So at this point, it's really table stakes in the software industry to have a third-party audit for cybersecurity. And finally, is your service and AI features compliant with CMMC? If you need CMMC certification, you've got to make sure that any cloud you're using that is going to get access to that protected data meets all the requirements we discussed earlier. So how can AI help you in the front office? Well, it can surface objective information faster in a clean, intuitive way so that you can make more informed decisions. And this is where Paperless Parts helps. Our goal is to not automate every step of quoting because you know your shop and customers and what's going on in the industry. So to that end, here are our guiding principles, and we hope lots of companies adopt similar ones, and these guide how we use AI in our product. So first of all, for security and compliance, the AI-supported features in Paperless Parts can be used by customers with CMMC Level 2 requirements. So we don't send any customer data to any non-compliant third-party tools like ChatGPT, and all the development and training occurs in boundary, meaning the data it's trained on never leaves the FedRAMP assessed system. As for use of customer data, you have very limited use of customer data for training, and we never use things like pricing configuration, like your P3L or formulas or your variable values for use in training. That is completely your information. For transparency and human review, the application calls out AI-generated suggestions so that the human user can very quickly see where they're coming from and check whether they're right. And we use testing and continuous improvement. So feature performance is always tested prior to launch, so we know how often it's going to work on real data, and the product is instrumented to support continuous improvement. So we know how it's doing based on how users accept or don't accept the suggestions, and we work to make it better. So when your tools are helping you get your job done, AI makes suggestions and humans make decisions. So let's actually walk through an AI-powered workflow. And does anyone watching this, you ever work with engineering prints, right? When we started Paperless Parts almost 8 years ago, I thought for sure prints were going to go away and everyone was going to be using model-based definitions. Well, that hasn't happened. Even though there's been better tools for that for 20 years, seems like no one cares, and there are just prints attached with almost every quote. So when an estimator has to deal with a quote, there's really 4 key activities. The first thing they need to do when they get a big tech package is set up the parts. They have to figure out which files go to which quote items, how many things they're being asked to quote, do drawings go with certain models, and so on. So they're looking for part numbers, revision, description, BOM tables to help them just understand what they're being asked to quote. Next, estimators need to quickly disqualify parts, right, that aren't good fits for their shop. So they're looking at part size. Are these parts too big or too small for me? Are there tight tolerances that I don't like to manufacture? Difficult materials that I don't want to work with? Processes I can't do? For CNC, maybe there's weird surface quality or positional tolerances that aren't a good fit for my shop. Then, once we decide we actually want to quote it, you got to build the router. So filling out our router is really the first step to costing. You need to figure out materials and processes and specs that dictate them. You'll need to look at the types and numbers of unique features, so holes, right? Drilling, are there countersinks and counterbores for CNC? Are there tapped features, meaning thread callouts? And then finally, once you have your router, you can actually cost the requirements and essentially calculate all those costs. So you're looking at key measurements, counts of features, worst tolerances, and then estimating based on the notes. So here's how that can work in Paperless Parts with some AI assistance. And I've looked at a lot of prints, and the biggest takeaway is just how varied they all are. I don't want to shock anyone. Engineers are not always very disciplined about how they make their prints. They can't even always fill out a title block, right? And even something as simple as pulling part numbers, revisions, and descriptions can become a headache. And it's actually surprisingly hard to automate if you've ever tried. So we've introduced a series of features called Wingman, right? So a co-pilot tries to fly the plane for you, but the Wingman has your back and makes sure you don't miss things. But you're still in charge, very much driving the process. So with that in mind, some of the things we do, we've introduced this concept of assistance, right? And there's a lot of data input you need to do when working with prints. So whenever possible, we're going to make suggestions about what the input is for those things. So in this case, for part number and revision, we're going to suggest and lets you know exactly where on the print we found that value so that you can very quickly get that information into the system. We'll also look for different callouts in your prints to help you look for things you got to take note of when quoting, right? Materials, specifications like mil specs or ASTM specs or even OEM specific specs. And then process words like anodizing, right? And then things like threads. In this case, a universal thread callout. So it's those things that help you very quickly find things that are going to drive cost on this print. Paperless Parts with Wingman helps you quote efficiently and reduce risk, especially when quoting with prints. Thanks for watching. If you're ready to learn more, check us out at paperlessparts.com.